So, hello friends. Today we are going to be doing a very, very important topic, and that is surface areas and volumes, which starts in class 8 when we start talking about 3D objects, and then moves on from cubes, cuboids, and cylinders to spheres, to cones and cylinders in class 9. So, today we are going to be taking up for class 9 and partly for class 10 as well. So, let's start. Surface area, as you know, we've done in earlier classes also. It is basically a combination, the area of all the surfaces that are there. So you can see how many surfaces are there. One, two, three, four, five, and six. A sixth surface. So there are six surfaces. To take the a combined thing of all the surfaces, whether it is L into B from here, L into B from the back, there'll be a separate length and breadth from this side, there'll be a separate length and breadth from this side. So adding up all the six areas is going to give you the total surface area of that shape. And this is an important concept because you then are able to find out what is the sheet area that is required to make a certain something, what is the area of the wall which you need to kind of paint, what is the cover for a particular box that is required. So that will give you a thing. And you can also have an open box where the lid is not there, so the parameters will change slightly. We're going to be now quickly moving into cylinder. So here it is. Our topic for today is going to be surface areas and volumes, cylinders, cones, and shapes. Volumes is the amount of space in a particular object as to how much of liquid you can put in, or what is the kind of quantity of anything that you can put into a 3D object, whether it be a cuboid, tube, sphere, or whatever, like the ice cream cone that you have in your McDonald's, etc. That basically is the volume of the cone which you are holding in your hand. The cone would be something like this, a very minuscule cone at this point. So this is what your whatever goes in into it is going to be the volume that is going, right? So moving on, if I have to talk about cylinders, what are cylinders? Cylinders are nothing but they are 3D objects with a circular base. Now, if you can see this is a 3D object. It has a circular base. Now I'm showing you the circular base on the top, a similar circular base below. So there are 3D objects with a circular base. In your regular life, you must have seen them as uh, powder containers, your Pringles container, your container which is a hit container. So these are your examples of cylinder shapes. Coming to a cone, as I told you, a cone, the most common example that you would have seen would be your ice cream cones. You have your birthday caps. You have your regular. So this is your cone. You can have it inverted, so that becomes a birthday cap or a clown cap. This it can be your chana cone or your ice cream cone. So what do you see? There's a circular base, the circular base on which the cone stands, and this is a slant base which narrows and comes into a vertex. Is that okay? So 3D objects with a circular base, a curved surface area that gradually ends in a vertex. This is what a cone is. Finally, a sphere. A sphere is nothing that uh, but your ball that you see anywhere and everywhere. A globe is an example of a sphere. So it is a 3D shape where every point on that surface is going to be equidistant from the center. Moving on. Cylinder. As I told you, a cylinder is nothing but a curved surface with a circle base on the top, a circle base below. Now, if I were to open up this cylinder and show you, just let me open this out for you. Here, see, this was my cylinder. I've opened it out. And what has it become? It's become nothing but a rectangle. Now, this is what has been shown in the slide also. You have, when it is cut from the height, it becomes a rectangle. And what do you have? The circular base here, what is the length of the rectangle going to be? It is going to be nothing but the circumference of the circle which was below, and that is 2 pi r. And what is this going to be? The breadth of the rectangle is going to be nothing but the height of the cone. So how are you going to get the length, the area of this rectangle? The area of the rectangle is going to be length into breadth. In this case, the length is 2 pi r and the breadth is h. So the lateral surface area, or that is the surface area along the sides, is nothing but 2 pi r h. So this is what has been derived. The area of the curved surface is 2 pi r h, and each of the circles, you're very well aware, what is the area of this circle? It is pi r square. So you have a pi r square on the top, you have a pi r square below. So your total surface area then becomes 2 pi r h, which was a curved surface area, and 2 pi r square because of the two curved surfaces, two circles on the top and below. So that's 2 pi r square. When you pull out 2 pi r from both these terms, what do you get? You get an h plus r. And so simplified, the surface area of a cylinder is nothing but 2 pi r into h plus r. If you are asked to only find out the curved surface area, you will restrict yourself to 2 pi r h. If you are asked to find out the surface area of an open container, the lid is say made of plastic and the rest of the container is made of tin. So you would have 2 pi r h for the lateral surface area, and for the other part, then you would be having just one circle. And so that one circle would be nothing but that one circle. So it will be 2 pi r h plus only pi r square. Is that okay? An example, a very quick example. A soda can has a radius of 4 centimeters and a height of 12. You need to calculate its surface area. So how would you calculate the surface area? It would be nothing but 2 pi r here is 4. Inside, it would be h plus r. H is given as 12. And so you, using the value of pi as 22 by 7 or 3.14, you'll be able to find out area. As you know, always the unit for area is the square of the units. Since everything was given in centimeters, your area becomes centimeter square. Okay. Moving on, how do you calculate the volume? So let's look at this. And we said that you have one curved surface, another disk, another disk, another disk, another disk, another disk, right till the top. How many times is this disk going to come? It is going to come h times. So what is the volume going to be? 2 pi r, how many times? H times. So that's how, sorry, not 2 pi r, it's going to be pi r square because the area of the circle is pi r square. Pi r square, 1 time, 2 time, 3 time, 4 time, 5 time, and up till h. So the entire volume that can go in is pi r square into h. And so that is area of base into height. And you have your formula coming up as pi r square h. So that was the volume of a cylinder. Now, volume of a cylinder, whether it be an open cylinder or a closed cylinder, the volume will still remain the same. It is only the surface area which will differ. Coming next to a cone. As I was just showing you, a cone can actually be thought of as a part of a circle, as a part of a sector of a circle. Now, if I look at this was a circle, right, which I took just one of the sectors. And when I take the sector, this becomes your slant height, right? This becomes your slant height. This is the radius of the circle at the bottom. And this here becomes your perpendicular height. So the slant height is known as L. The perpendicular height is known as H. And obviously you have the radius of the circle below. So how do I calculate the total surface area? The total surface area is going to be this area, which will actually get folded up like this into the cone, plus you will have the area of the base, which is again a circle. So area of a base, you know very well, it is pi r square. Please follow my cursor, it is pi r square. And when you have to find out the area of this curved surface, which is looking at more triangular in shape, it is going to be pi into radius of the base into the slant height. So pi into r into L. This is what you're going to get. So your total formula then becomes pi r square plus pi r L, which is pi r pulled out pi r into r plus L. Now, this has applications when you are, say, making a tent. In a tent, you have to have the surface area as well as the base. So you may be having something which is the total surface area. You may be having, say, just something where you need to make a conical container In that, you do not require the base, so you'll just be requiring the curved surface area, which will come out to be pi rl. So that's how you calculate the surface area of a cone, whether it is the total surface area or the curved surface area. Now, curved surface area is what is actually known as the lateral surface area in shapes which are having straight lines. Like in your cuboid or cube, you will be calling it the lateral surface area, but in the cylinder or in the cone, you will be calling it the curved surface area. So the total surface area is always going to be an addition or a sum of the curved surface area plus the area of the base. Area of the base in both the cases is the area of the circle. In the cylinder, you have two circles up and down. In the cone, you just have one circle below. So that's how you work on the area of a cone. Now, this can be done with a practical example. Suppose you have a cone and a cylinder of the same height. Suppose this height is the same. You fill this up 3 times and empty it out into the cylinder 3 times of the same height. What will you notice? That the volume which you could fill up in the cylinder is exactly 3 times that which you could fill up in your cone. So this you can see here with the help of this demonstration. One cone inverted, another with the base below, second cone again inverted. 3 cones together. What you put in inside these 3 cones would be equal to the volume of a cylinder with the same height. So, keeping that in mind, remember what did we find out the volume of the cylinder to be? We had found out the volume of the cylinder to be pi r square h. So, if that is the volume of a cylinder, I need just 1/3 for the volume of the cone. So, it's going to be pi r square h divided by 3. So, that is how you get the area for the volume of the cone. Is that okay? So, we've gone across two major formulas. Let's just have a quick recap. For the cylinder, the total surface area comes to be 2 pi r square plus 2 pi r h. For the cone, it comes out to be pi r square plus pi r l. For the cylinder, the volume is pi r square h. For the cone, it is 1/3 of pi r square h. Right? And otherwise, if you're given just two things, you're given the volume of the area of the base and the height, you can still find out by multiplying the area of the base into the height, you can find out the volume of the cone or the cylinder. Is that okay? With this, we come to a sphere. A sphere, just let's look at it like a cone, sorry, a cylinder, with its edges absolutely crumpled up to make it into a circle on the top also, a circle below also. And if I then open it up, my surface area, then again by the same formula is going to be base into height. What is this when it opens up? We already know it is going to be nothing but the, what is it going to be? It is the circumference of the cylinder. So it's going to be 2 pi r. So that's how you got your 2 pi r. And then from the center to the top, it is r, that's the radius. Again, from the center to the bottom, it is again another r. So when you're talking about the surface area totally, it's going to be 2 pi r into the two r's, one going up, one going below. And so the total surface area comes out to be 4 pi r square. Just let's think of what the surface area of a hemisphere can be. If the total surface area of the ball is 4 pi r square, the shell of half, that's the hemisphere, the shell, the area is going to be 2 pi r square. And what's the area of the base going to be? The area of that hemisphere is going to be pi r square. And so totally it's going to be 2 pi r square plus this pi r square niche. And so you get it to be 3 pi r square as the area, the surface area of a hemisphere, total surface area. Otherwise, for a square, for a sphere, your surface area is going to square. Is that okay? Coming next to the volume of a sphere. Remember when we were doing the area of a circle, uh, the way we used to derive it, we used to make it into triangles, inverted triangles, inverted triangle, inverted triangle, and we divided the entire circle into triangles. Similarly, what we are going to be doing is, it's like we pulled out, like, have you ever cut out a watermelon and pulled out a slice? So does it look like this slice here? What is this slice? This slice is nothing but the shape of a pyramid. Now, if you look at it, if I look at the sphere and I say it's millions of such pyramids put together, what is my volume going to be? It is going to be the base of the entire pyramids into the height of the pyramids. So each one of them is going to be pi r square into 2. So if I just look at it from here, now for each of these pyramids, what is the volume of each pyramid? If I say the base of this one is B1, the height is R. We've already seen what is the height of a cone. It is by 3. So base 1, 3 by R. Similarly, for the second pyramid, base 2 R by 3, and so on. It continues up till the last cone, which is Bn R by 3. Having done that, I pull out my R3 and inside I'm left with B1, B2, B3 right up till Bn. But what is B1, B2, B3? These are all the bases of all the cones right along the sphere. So that is nothing but actually the surface area. So it is nothing but R by 3 into 4 pi R square. And so what do we get actually? We get the volume of the full square to be 4 by 3 pi R cube. Is that okay? Having said this much, let's move on to some problems. Now, I would like to do them practically in front of you so that you understand. The questions are listed here in the slides, and I'm also going to be doing them on my notepad in front of you. Yes, so this is my notepad. The first question is that a cylindrical water tank has a radius of 3 meters and a height of 8 meters. You need to calculate its TSA. The TSA means total surface area. PSA, as we know, is nothing but the CSA plus the area of the base, right? One second, just give me a moment. So this is CSA plus the area of the two bases. We've already said this is CSA is nothing but 2 pi RH followed by the area of the two bases. It will be 2 times pi r square. So this is 2 pi r square. Let me just erase that one side. So having said this, it becomes 2 pi r into h plus r. I'll just use a highlighter to be able to make you understand. So your formula then becomes 2 pi r into h plus r. You know your pi to be 22 by 7. R has been given to you as 3 and the height has been given to you as 8. Whenever you are doing a sum, please be sure that you actually write down what is given to you right in the beginning and what you need to find out also to find and what has been given. Having worked that out, I'm not going to do the calculation for you. You will get it to be 207.43. Why meter square? Because the units of my height and my radius were given in meters. Is that okay? So that was my TSA. That was the first question. I was also asked to find out the volume. Volume formula is pi r square h. What was R? R was nothing but 3. H was 8. So 22 by 7 into this is going to give you 226.29 meter cube. Please be careful. You're not going to be allowed calculators, at least up till the 10th in your exams. So your calculation should be very, very strong. Did you notice your unit now has become cube rather than meter square? Why? If I break this up, this is actually pi. You're multiplying one variable, a second variable, and a third variable. So m from here, second m from here, third m from here. So in all it becomes meter into meter into meter, which is nothing but meter cube. And that is how you get your units to be meter cube. Is that okay? So that was your first question. The second question was the surface area of a cylinder this time is given Okay, very, very important thing. Now, when you're given just the surface area and you're not actually told whether it's TSA or whether it's CSA, you have to perforce take it as the total surface area. Please remember again that if you are just told the surface area of a particular object, you have to consider it to be the total surface area. That's given to you as 264. The height is given as 11 centimeters. What is its radius? Now, what is the formula for TSA? As usual, first I will write down what is given to me. TSA is given. What is given to me? Height is given. What you need to find out is radius. So TSA formula says TSA is equal to 2 pi r plus h. TSA was given as 264. So let me get this up slightly. 264 and substitute all the values. And what you get? You get this to be r square plus 11r on the right. And on the left, you get this as on cancellation, you're going to get this only as 42 is equal to r square plus 11r. Now, a little bit of factorization will come in. 42. What are your factors of 42? The factors of 42 are 1 into 42, 2 into 21, 3 into 14. Otherwise, you also have 6 into 7. From which of this combination of factors can you get 11? You can't get it as 42 minus 1 or plus 1, so this is not possible. 22, 21 plus 2 minus 2, you are going to get 19 or 23, not possible. 14, 14 minus 3, 11. Yes, we got it. So 11R is going to come out as a combination of 3 and 14. And this is what you're going to pick up. So this is going to be R square plus 14r minus 3r, because plus 14r minus 3r is actually going to give you plus 11r, which is what we required as the middle term. This method of factorization, if you remember, it is referred to as middle term splitting. So this becomes r square plus 14r minus 3r minus 14. You get your factors as r minus 3r plus 4 is equal to 0. When the product of two factors is 0, it means that one of the factors has to be 0, because when you multiply that 0 with something, you're going to get 0. So either r minus 3 is going to be 0, this one here, or r plus 14 is going to be 0. So let me try and put r minus 3 equal to 0. R minus 3 equal to 0 gives me r is equal to 3. R plus 14 equal to 0 gives me r is equal to minus 14. Now, this is very, very strange. Can you have a radius as a negative number? Not possible. So, definitely then r is only going to be 3 centimeters. So, the radius of the cylinder comes out to be 3 centimeters. That was your second question, right? Now, coming to the third one. A cylinder and a sphere have the same volume. What was the volume of a cylinder? Pi r square h. What was the volume of a sphere? 4 by 3 pi r cube. So if the cylinder's radius is 5 centimeter, height is 10 centimeter, given the radius as 5, height as 10, do you all agree that we can actually find out the volume of the cylinder? You got it? Now, once you got the volume of the volume of the cylinder sphere formula just involves one variable, and that is r. From there, can we find out the radius of the sphere? So let's start working towards it. And I'm using two different uh, notations for the radius, r1 and r2. Why? Because r1 is for the cylinder and r2 I'm going to be using for the sphere. So volume given as pi r square h for the cylinder, then I substitute the values pi r square h and I find out my volume. That volume then would be equal to 4 by 3 pi r cube, and from there I can find out my r. I've left this as a sum for you to do. Now coming to the practice questions on spheres. A spherical balloon has a radius of 15 centimeters. Calculate its surface area and volume. Very, very easy sum. You know your surface area formula. It is 4 pi r squared. R is already given to you. You can find it out. Similarly, you know your volume formula 4 by 3 pi r cube, and you can find out your volume. So just be careful. What is the unit going to be? The unit in this case is going to be, for the area, it is going to be centimeter square, and for the volume, it is going to be centimeter cube. Surface area of a sphere is given as 256 pi centimeter square. What is its radius? Again, we know the surface area for a sphere formula is 4 pi r square. That has been given to you in the question as 256 pi. That being given to you as 256 pi, equate both the sides. You have 4 pi r square is 256 pi. I think the pi has not come out very well. So the pi and the pi are going to cancel. I have actually taken by r square that side. So r square is equal to 250. R square is equal to 256 pi upon 4 pi. And that finally gives you your r square as 64 and your r as 8 centimeters. Is that okay? Please ensure that you write your answer statements as well, right? A hemispherical dome has a surface area hemispherical. This is what I was talking to you about. I've drawn the diagram here. You will be able to understand what I was telling you otherwise also. The sphere here is this one. So here you are know what is your surface area for this entire thing. It is 4, I'll use this pen, 4 pi r square. Now, if you look at the hemisphere, it's half above, half below. But there's also this surface in between. Let me use another color to make you understand the other surface in between. Let me use this color. So this surface in between is the area of your circle in between. So from the top, you have 2 pi r square. What is the area of that circle in between? That is pi r square. So together, what do you have? Your area for the hemisphere actually becomes 3 pi r square. Is that okay? So now coming back to the sum, you had to find out what you were given was TSA of the hemisphere was given as 200 pi m square. So in this case, what are we going to say? TSA is given by 3 pi r square, and that 3 pi r square is given as 300 pi, from where you can find out what your r is going to be. Is that okay? So practice questions on cones. The volume of a cone has to be found out. The height is 9 and the base is 13 centimeters. And this time, you don't have to break your heads trying to do the calculations. You have to find out the answer in terms of pi. So don't try and put any value of pi. You can simply just say that pi is, you're going to be taking pi without saying it is 22 by 7 or without saying it is 3.14. So let's look at this. For the cone, the height is given as 9. Radius is given as 13 centimeters. Volume formula we know is 1/3 pi r square h. Put in all the values except for pi. And so easily done. You get 13 into 13 into 3, which is nothing but 507 pi centimeter cube. Again, why centimeter cube? Because we are finding out the volume. It's multiplying 3 variables, r, and h. Is that okay? So that's how centimeter cube. Again, answer statement, a must, without which you may tend to lose marks. Next question. The volume of a cone is 300 centimeter cube. Height is given. The radius has to be found out. Again, whatever is written has to be mentioned in the beginning itself. Volume is given, height is given. What has to be found out? Radius. Put down the formula. It is 1/3 pi r square h. Substitute the values and you will find your radius square comes out to be 700 by 22, which actually is 100 upon pi. That is radius square. Radius kaise aayega? You will have to take the square root of either side. So that's going to be 10 upon root pi. Is that okay? Remember, we had to find out the answers in terms of pi. So that pi was not a problem here. Two cones have the same height of 8 centimeters and the radius of the first cone is 3 centimeters. Radius of the second cone is 6 centimeters. You need to compare their volumes. Very cute, very easy question, but often such questions come. Since there are two cones and I've been given separate radiuses and heights, I will label them as R1 H1 and R2 H2. For cone 1, it's going to be pi R1 square H1. But we've been told that the have the same height of 8 centimeters. So H1 is going to be H2, which is nothing but 8 centimeters. So we are going to be equating both sides, and we need to find out the ratio of the volume of the first cylinder to that of the second cylinder. So I write that as a fraction pi pi cut H1 and H2 because they are the same, they also cut. You're left with R1 square upon R2 square. R1, remember, was 3, R2 was 6. Cancel, you get 1 is to 4. So the ratio of the two volumes is nothing but 1 is to 4. These are some very, very basic questions as far as your cylinders, etc., are concerned. Uh, if you want to get back to me, you know where to get back to me. My numbers are flashed on the screen and you can get in touch with me. I offer classes up till the ninth for maths and up till the 12th for English. Thank you. Have a nice day.